This video is over graphing quadratic equations in vertex form. Okay, in vertex form. So, a couple things we need to know. What is vertex form? Okay, vertex form, actually, if we think about it, it's almost like absolute value when we graph those. Okay, except we don't have the absolute value bars anymore. We have the parentheses, and we have a square on it. So, if I talk about the vertex form equation, and I have A, B, and C, the Y and the X always have to be there, but I have the A, B, and the C. So a couple things. If A is greater than 0, then the graphical quadratic equation, it goes up. If A is less than 0, it goes down. Guess what? That's exactly the same as an absolute value equation. With this being in vertex form, well, the vertex is the fastest thing we could find, the easiest thing we could first do. So in order to find the vertex in a vertex form quadratic, we are going to take the opposite of B, comma, C. That's the vertex. Okay? Whatever B is, we flip it in the opposite of B, and then whatever the value for C is, that's our Y value of the vertex. So if I come back to this equation up here, okay, that is A, that's B, and that's C. So the vertex says I take the opposite of B. So that's 4, comma, negative 4. And then, remember, C is negative 4. So I'm going to plot that. So starting at the origin, I go right 4 and down 4, and then this point right here is my vertex. Now, there's a couple things we need to know for graphing quadratics. So we have the vertex. That's one thing we need to find. The other is we need to find what we call the axis of symmetry. What the axis of symmetry is, it is basically a vertical line through the vertex that tells us that the graph is split in half. So if I find some points to the right of that line, graph them, then I can reflect it over, and that would be the points on the other side of that line. So that's what would give me my shape of my graph. So the axis of symmetry is an equation where x is equal to some number. That number right here is just the x-coordinate of the vertex. Okay? So our axis of symmetry in this particular equation is x equals 4. That's our equation of the axis of symmetry. Now, what we usually do with the axis of symmetry is I go and find x equals 4, and I dot my line that goes through my vertex. That helps me, as the person doing it, saying that everything to the right of this line that I graph will reflect over to this side. Okay, that's how it's going to work. So now how do we actually graph this? Okay, a couple things that we need to know. One is, because it's symmetric, I only have to do one side of the axis of symmetry. I could either do the left or the right side. And I'm going to choose the left because the left are numbers that are smaller than 4. It's like 3, 2, 1, 0. Okay? So I'm going to choose 3. And what I do with that 3 is I plug it into x. I substitute it into x. So 3 times 3 minus 4 squared minus 4. Now I solve. So that's 3 times negative 1 squared minus 4, which is 3 times 1 minus 4, which is 3 minus 4, which is negative 1. So if I plugged in 3, I got negative 1. Well, because the axis of symmetry is symmetric, then that point is 1 unit away from the axis of symmetry, so I have to go 1 unit away to the other side. and that is also my reflected point, reflecting it over. When you graph a quadratic, you need 5 points. So that's only 3. I got the vertex and 2 more. Well, another point I'm going to choose is 2. So I'm going to plug in 2 and solve. 3 times negative 2 squared minus 4. 3 times 4 minus 4, which is 12 minus 4, which is 8. So if I plug in 2, I get 8 way up here. Now if I look at it, that's 2 units away from my line. So 2 units in the other direction are my reflected point. So now this graph has 5 points, so now we're good to go to draw it. When I draw one of these graphs, it's a U, not a V. It is a U. It's called a parabola. Okay, it's called a parabola. Looks like a U, or it could be a U upside down as well. Doesn't matter, but it looks like a U. This one here looks like a U going up because A is greater than 0. So at the bottom of my vertex, it looks as though I have like a little rounded part. And then I come up through my points, and then I come up through my points with arrows, and you have now graphed your line. So what have we done so far in this particular problem? 1, we found the vertex. Remember, it was the opposite of B, comma, C. Step 2, we found the AOS, the axis of symmetry. The axis of symmetry, remember, is the x-coordinate of the vertex. Number 3, we graph parabola by choosing numbers to the left of AOS. Plug them in and solve. So that's what we did to get the other 4 points for our graph. Now the fourth thing that I have to do is I have to find, is it a min or a max, and then find the value of the min or max, okay? So how do we do that? Well, when A is greater than 0, we have a minimum. Why? Well, if I look at the graph here, A is greater than 0 because the 3 is greater than 0. So if I look at the graph, the vertex right here is at the smallest most point it could ever be at. So that is why this particular one is going to be a min. If A was negative, then it would be a max because the graph would be flipped and it would point down. Now it says find the value. What value? The value is what that is in terms of the y coordinate. So the minimum in this particular instance is -4. If you notice, this is the y coordinate of the vertex. Okay, that's how we graph equations in vertex form. So that is what I need. I need those 4 steps. Okay, let's look at this particular equation. And first I need to do is find the vertex. Because this is in vertex form, it's really easy to find the vertex. Okay, so remember the vertex was the opposite of B, comma, C. So here is my B value. The opposite of B is 2. The C value that's out here, it doesn't look like there is any, but there is. It's a 0. So what happens is when I graph that, I get 2 zeros. So my vertex is right on the x-axis. The second step, I need to find the AOS, the axis of symmetry. Remember, it's an equation, x equals, and whatever the x-coordinate of the vertex is. So x equals 2. So at that point, I am going to draw a dotted line down my graph. The third step was I'm going to pick numbers either to the left or to the right. The last problem I did to the left. This problem I'm going to also do to the left. So I'm going to pick numbers to the left of AOS and plug in. So I'm going to plug in numbers, okay, into the x value of my equation. So I'm plugging in 1 because that's to the left of 2. So negative parentheses 1 minus 2 squared, which is negative parentheses negative 1 squared, which is negative parentheses 1, which is negative 1. So I plug in 1, I get negative 1. And we see that that's also 1 away from the line, so 1 away from the line in that direction is now plotted. Again, that is my reflected point. But again, I said I need 5 points, so I only have 3. I need 2 more. Well, let's plug in 0, because that's another one to the left of 2. So I get negative, comma, or negative parentheses 0 minus 2 squared, which is negative parentheses negative 2 squared, which is negative parentheses 4, which is negative 4. So if I plug in 0, I get negative 4. That's 2 away from the line. So 2 away from the line in the other direction, that is now also plotted. So I have my 5 points. So again, remember we have a U down there, and we come down. So that was step 3. Step 4. Remember, I need to find if it's a min or a max. How do we do that? Remember, if A is greater than 0, it's a min. Is A greater than 0? What is A? A in this case is negative 1. That's not greater than 0. So A, when it's less than 0, is a max. So our answer is a max, because that's the vertex right here is the highest point it can be on the graph. That's why it's a maximum, max. What's the value? Remember, the value is whatever the y-coordinate of the vertex was. So the y-coordinate was 0, so my max value is at 0. This concludes graphing quadratic equations in vertex form. If you need help with standard form, please watch the next video.